Sequences and series review, doing some word problems 24 through 30. In each problem, we're going to ask if the sequence or series is arithmetic or geometric, and then are we looking for a particular term, or are we dealing with a sum or a total? Number 24, the grocery store is building a pyramid of cans. The first row has 5 cans, so let's go ahead and label that as the first term. Each successive row has 2 additional cans we're adding. Common difference is 12. And we'd like to know how many cans are in the 12th row. So we're looking for a term. That means we'll use an n value of 12 with our arithmetic rule for sequences, which looks like this. And then we plug in the information we have. We're looking for the 12th term based on a first term of 5, a common difference of 2, and a term, number 12. And evaluating all that gives us 27 cans in the 12th row. All right, on to number 25. In a stadium, our first row has 10 seats, and each successive row triples. That's multiplied by 3, so we know that's a geometric. We also know the first row is 10, so we can go ahead and label that. And we're looking for the 10th row. So we're looking for this term in a geometric sequence. Here's the formula we're using. And we know that n is 10. So we have everything we need to plug in to find that 10th term. Based on our first term of 10, every row tripling, and then also looking for the 10th row. So our 10th term, sorry about that, will be 196,830 seats. In number 26, 18 seats in the first row of an auditorium. Each successive row has 3 more seats. So we're adding 3. That would be our common difference. So we know we're dealing with something arithmetic. We have 18 seats in the first row. Go ahead and label that. And we are looking to see how many seats are in the first 50 rows. So we want to add up all of those 50 rows. So we're looking for a total, which means we're looking for a sum or a series. And that gives us n of 50. So with the information we have, if we don't want to do any additional work, we'll use the longer of the 2 arithmetic series formulas to find the sum of the first 50, which is n over 2. 2 times our first term plus our common difference times 50 minus 1. Of course, as you're evaluating, don't forget PEMDAS. And when we evaluate that on the calculator, we get 4,575 seats. In number 27, we have a pyramid with 6 cans in the first row. Each successive row doubles. We're multiplying by 2. This is going to be geometric. How many cans are there in the first 26 rows? That's looking for a total, which means we're dealing with a geometric series or sum. So only one formula to use because this is finite, where n equals 26. The sum of the first 26 is our first term times 1 minus our common ratio of 2 to the power of 26 all over 1 minus 2. Now it's just a matter of plugging it into the calculator and getting our completely unrealistic answer. All right, let's put some commas in there. 402,653,178 seats. No, that's not seats, that's cans. 4 million cans. Good luck building that. All right, let's go to 28. Find the number of rows a theater has if there are 5,460 seats. Someone is giving us a sum. The first row has 3 seats, and each successive row adds 4 seats. We know our common difference is 4. Unfortunately, we don't know how many rows, what our n is. Since we were not given the last term, which would be the number of seats in the last row, we have to use the longer of the 2 arithmetic sum formulas. So I'll write that out for you, and then we'll fill in what we know. We know the sum. We don't know n, so we have to leave that as our variable. We do know the first term is 3. We do know the common difference is 4, but again, there's n, and we do not know what that is. So we need to do a little algebraic simplification. Can work within our parentheses on the right-hand side to give us 6 plus 4n minus 4. Combine like terms. Give us 4n minus plus 2, excuse me. And then these are all evens. We can just go ahead and distribute, leaving us with 2n squared plus n. And here's where we see that it's a quadratic. And whether we choose to factor or use a quadratic formula or use technology, we're going to make it equal to 0 first. So let's subtract 5,460. And then we can go ahead and go to the TI and use our polynomial solver to find a reasonable n value. We're using the TI to solve number 28, finding our n value now that we have a quadratic equal to 0. So we're going to use the polynomial solver that's in apps. The apps button is next to your math button. And we're looking for the PolySmilt 2. May not be in the same position, but that is the app that you want to use. And we're finding polynomial roots. So 1 is just fine. We have a quadratic, so power of 2. Everything else you can leave the same. When you see that next button, it's going to line up on your screen right above this graph key. So hit the graph key to go to the next. And you'll see it set up as a quadratic in standard form. We just need to make sure we enter the coefficients and the positives and negatives. So our a value is 2. And then you can hit enter. It's going to ask you, is the next term positive or negative? Our term is positive, and it has a coefficient of 1. But then our last term is minus 5,460, so we're going to hit minus, and then 5,460, and hit enter. And then your solve key lines up right above the graph key, so hit the graph key to solve. And we have an integer, so n could be 52 or n could be negative 105 over 2. So n is how many terms we're adding together. It must be a natural number, so 52 is our only reasonable answer. There's our reasonable answer if you want to remind yourself that there were 2. The other one was negative 105 over 2. Of course, that's unreasonable, so we'll eliminate that. On to number 29. We're hired at an annual salary of $40,000, and we get an annual increase of 2%. What will our salary be when we begin our 5th year? So let's note what we have. Our first term is $40,000. Because we're increasing with a percentage, that tells us it's geometric. We're looking for our 5th year, so that's our unknown, would make n equal to 5. And our common ratio is going to be 100%. We keep 100% of the salary they've promised us, plus the 2% raise. So every year is 102% of the previous year. But to use a percentage correctly in a geometric sequence or series, we must turn that into a decimal. So our common ratio will be 1.02. Then we simply go to our geometric formula, looking for our 5th term, based on our first term of 40,000. Common ratio 1.02, and we're going to raise that to the power of 5 minus 1. Since we're dealing with dollars and cents, decimals will be just fine. And in our 5th year, $43,297.29. And our last word problem, a ball is dropped from 20 feet. Each time it strikes the ground, it bounces to 75% of its previous height. What is the height of the ball after 3 bounces? So if it drops from 20 feet, we don't know how far it's going to bounce the first time. We do know it will be 75% of 20. So we do not know the first term, but we have enough information to calculate that. 20 feet is the distance it falls, and its bounce will be 75% of 20. So our first bounce is 15. That's what we must use in our equation because we're keeping track of the bounces. Our common ratio, of course, is 0.75. No need to add or subtract. That is the height of the ball. And we are looking for the 3rd bounce. So our n value is 3. So geometric, because we have a percentage. And to find our 3rd term, we'll start with our first bounce, which is 15. 0.75 is our common ratio. And our exponent is 3 minus 1. To the calculator to find that 8.44 feet is the height of the 3rd bounce.